and vulnerabilities, it was slowly being replaced by Advanced Encryption Standards. In this video, I'm going to introduce you all to what exactly Advanced Encryption Standard is all about.
So let's continue. So I was saying that depending upon the key size, there will be different rounds of AES. So if I'm using a 128-bit key, I will be using 10 rounds of AES. Similarly, if I'm using a 192-bit key, I will be using a 12-round AES and 14 rounds for 256-bit keys. Right? So this is जो आपको diagram दिख रहा है सामने, that is nothing but AES 128. So what I'm showing over here is the plain text is of size 128 bits. It is further, we can say that it is nothing but 16 bytes, right? 16 bytes is equal to 128 bits. उसको हमने कैसे break किया? We have converted that into a 4x4 matrix. So 16 bytes का अगर मेरा plain text है, so it gets converted into a 16 by 16, 4x4 का matrix, जहाँ पे each and every cell जो आपको cell दिख रहा है, that cell corresponds to 1 byte. So in short, it is 16 bytes का matrix, जो हमारा initial matrix हुआ. ये हमने लास्ट लेक्चर में भी पढ़ा. So now what happens is if you compare this with your DES का स्ट्रक्चर कैसा था? फीस्टल आर्किटेक्चर था, राइट? सो फीस्टल आर्किटेक्चर के केस में भी वही होता था कि द 64 बिट का प्लेन टेक्स्ट दो पार्ट में डिवाइड होता था एंड देन द टू पार्ट्स वर फर्दर सब्जेक्टेड टू मल्टीपल राउंड्स. यहाँ पे भी वही होने वाला है, बट इट इज क्वाइट डिफरेंट एज कम्पेयर टू फीस्टल. यहाँ पे कुछ हम उसको पार्ट में ब्रेक नहीं कर रहे हैं. जैसा का जैसा प्लेन टेक्स्ट है, वी आर डूइंग ऑल द ऑपरेशंस ऑन द प्लेन टेक्स्ट डायरेक्टली. So what happens next is that plain text goes through an initial transformation. We saw in the previous lecture also that initial transformation step बोलो या तो फिर जो internal rounds के transformations है, they are nothing but few XOR operations and few multiplications. So कैसे होता है वो हम लोग देखेंगे in depth, but अभी के लिए start के लिए we are assuming that plain text goes into some sort of a box, that is what we call as an initial transformation. ठीक है? Now initial transformation अगर मुझे करना है तो I need some sort of a key as well. तो key कहाँ से मिलेगा? Key is nothing but over here, as you can see, round 0 key, round 1 key, ऐसे करते करते कितने rounds के keys होंगे हमारे पास? Kindly let me know. AES 128 है. That means it is 16 bytes, right? तो अगर 16 bytes है, हर round में कितना key use हो रहा है? 16 bytes. So in total, how many rounds are there? Tell me that. जल्दी
10 rounds.
10 rounds, correct. So 10 rounds है, हर round में कितना की यूज कर रहे हैं हम लोग, कितना words? If you remember last time मैंने बताया था, there is a concept called as a word. अगर मैं 16 bytes की बात करूं, what is one word? एक word कितना होता है? How many bytes is
4
one
bytes.
word? 4 bytes, correct. So plain text का size कितना है? 16 bytes. So how many words are we going to require for each round? 4 words, correct. 4 words is nothing but 16 bytes. So for each round we are going to require, जो यहाँ पे दिख रहा है, हर एक round का जो key है, that is nothing but 4 words, right? So total rounds कितने हुए मेरे पास? अभी discuss किया था. 10 rounds. 10 rounds plus this initial round. So in short, there are 11 rounds. So I can say that 11 rounds into 4, that is 44 words का key is required for AES 128. Clear now? So यहाँ पे दिया है, if you see, round 0, round 1 से लेके round n. So this round number depends upon which AES you are performing. Right now I'm considering AES 128. So AES 128 में we are going to require 10 plus 1, 11 rounds, that is 44 words. Initial transformation is nothing but applying some sort of operation to the initial plain text. ठीक है? Let me clear this. So this initial plain text is of size 16 bytes, that is 4 words. I can say that this 4 words ka plain text goes inside the initial transformation, and the key for this particular initial transformation phase is provided using this key expansion function. Now you can tell me कि initially तो 4 word का ही key था ना मेरे पास. Initially it was nothing but 16 bytes. In the last lecture also we saw that we are expanding that key from 4 words to 44 words using a technique called as key expansion. So what is happening is in each round a 4 word ka key is being supplied using this key expansion function. So let's understand what this key expansion function looks like. जैसे मैंने अभी बोला कि each round में 4 words का key use हो रहा है. So can I say that This is the 4 word का key जो आपके screen पे दिख रहा है. Let me use the pointer. 16 bytes का matrix था. 16 byte के matrix को हमने 4 words में convert किया. This 4 word is nothing but one key और एक round का key. But what happens is this will provide me the key for the first or round 0. But what about the next 10 rounds? उसके लिए तो key generate करना पड़ेगा ना. And for that purpose we are going to make use of this function जो आपके screen पे दिख रहा है. ये हमने last lecture में किया था, but still I will explain once again. Okay, so kindly pay attention. What is happening over here is जो 16 byte का matrix था, initial matrix था. If you see the diagram, यहाँ पे diagram ध्यान से देखो. यहाँ पे भी एक initial matrix था key का, जिसका size कितना होना चाहिए? Considering I am using AES 128. How much?
16 bytes.
16 bytes, correct. It should be same as that of the plain text, right? So 16 bytes का input आएगा. That 16 bytes का input can be converted into 4 words. Same as the plain text, right? So that 4 word is nothing but this one, W0 से लेके W3 तक, W0, W1, W2 and W3. So what we are doing is we are simply copying each column into one word. So each column अगर मैं बोलूँ तो K0, K1, K2 and K3 is one word, is equal to one word, that is 4 bytes. In the same way, K4, K5, K6 and K7 becomes W1 and so on. So this entire term W0, W1, W2 and W3 is nothing but the round key for round number 0, using which we are going to calculate the next 10 round keys. Clear? So let's have a look at this diagram carefully. There is one value called W3. W3 goes inside a function called G, right? So W3 goes inside this function called G. G का जो भी output होगा, that is XORed with W0 and we will get W4. Any doubts with this so far? We'll understand G again वापस एक बार पढ़ेंगे. Okay, thanks a lot.
Sir.
So again हाँ बोलो.
Sir, but G function defined है यहाँ के मतलब वो
हाँ,
नहीं
G
बता.
function defined है. जो right side में आपको दिख रहा है डायग्राम वो G का है. मैं explain करूँगा अभी.
Okay, sir.
Okay. So in a nutshell, what happens is W3 goes inside G and G ka output is XORed with W0. So we will get W4. That W4 is XORed with this W1 and we will get W5 and so on. So this is a cyclic process. एक value मिलेगा तो ही अगला value find out कर पाएंगे. So we have to first of all calculate W4 and using that W4 we can calculate till W7. And this entire process goes on. Next stage में क्या होगा? W7 will go as an input to G and so on. Fine. ऐसे करते करते हम W43 तक find out करेंगे. If you see the diagram, previous one वाला, एक diagram दिखाता हूँ, एक second. Yeah. See this diagram. We are calculating from W0 से लेके W43, which makes it a 44 word का key. So ऐसे करते करते हम 44 words calculate करेंगे using this key transformation function. Now let's understand what is this G. So if you see, W3 goes as the input to G. What is W3? It is nothing but 4 bytes. Clear? So I can say that W3 को मैं ऐसे represent कर सकता हूँ. Let me show this. Yeah. So W3 को I can represent like this: byte 0, byte 1, byte 2 and byte 3. If you see, W comes as the input. So for the first G function, W3 will be the input, which is copied into this. So it becomes B0, B1, B2 and B3. Clear? So that undergoes few operations. Now let's see what is this G function in detail. So those 4 bytes, that is W3, goes through cyclic left shift by 1 position. ध्यान से देखो diagram को. B0, B1, B2 and B3 now becomes B1, B2, B3 and B0. So what exactly is happening? We are cyclically left shifting the values by 1 position. So B0, B1, B2 and B3 is now becoming B1, B2, B3 and B0. Is it clear so far? Kindly acknowledge.
Yes, sir.
Thank you. So now what happens is, now whatever output you got after rotation, that undergoes some kind of a substitution. So pay attention what is happening. B1, B2, B3 and B0, all the bytes are going into S boxes. Now if you're familiar with data encryption standards, we saw in the previous few lectures also that data encryption standard makes use of S boxes. Over here also we are going to make use of S boxes or substitution boxes, but the thing that is different over here is we are going to do all the operations in the Galois field. Let me explain what that is. All the operations will be done with respect to 2 raised to 8 operations. That is, no value can go beyond 2 raised to 8. That is, no value can go beyond 256. So if you see this table, it is basically a 16 by 16 ka table. Is it making sense? It is a 16 by 16 ka table. So what should be the maximum value? Kindly let me know. Kitna? FF, yeah, correct. FF, correct. So in terms of decimal, it is nothing but 256, not more than that. 0 to 255. Yes.
Yes, sir.
Yes, correct. Right. So that is the beauty of Advanced Encryption Standard. It is actually a standard where it restricts the numbers to maximum 256. So for example, if there is a number 259, then what will happen? If there is a number 259, simply it will be modded by 256. Mod le lenge uska and we will get the answer. Whatever is the answer. In this case, it will be 3. Getting it? So whatever operations are being performed, that is performed with respect to something called as Galois field or Galois field 8. So all the operations are restricted to 2 raised to 8 values only. Clear? Making sense? So this is again a standard table. You have to simply refer the table. Practically ऐसे ही करते हैं हम लोग. Table refer करते हैं and the values are being replaced. So what happens next is, if you see B1, B2, B3 and B0 is going through some kind of operation, and that operation is nothing but what we call as substitution. So let's consider B1. Let me take a number. Suppose B1 is 93. Okay. So if B1 is 93, what happens? That is nothing but 8 bits.
Yes, sir.
देखो ध्यान से. Yeah, fine. 8 bits हुआ. So अगर मैं 93 की terms में लिखता हूँ, it is very easy. The first half is 9, so it will be present over here. Second half is 3, it will be present over here. But what if I am having something like this: 1100 1011. So in that case, what we'll do is the first four bits will be considered for the left fraction, and the remaining 4 bits will be considered for the next fraction. So यहाँ पे क्या आएगा? 1100. It is 8421. So 11 का क्या हुआ? 12. So it is 12. 12 as in this case A, B, C. क्या होगा value? 10, 11, 12. So it is nothing but C. Making sense? Similarly, 1011 का value कितना होगा? 8 plus 2 plus 1, that is 11. What is 11? B. So it is nothing but B. Fine, itna part clear hai? So what will happen is, whatever is the first byte, that is 8 bits, if it is an hexadecimal value, no worries, कोई issue नहीं है, directly आप substitute कर सकते हो. Now understand what is happening. What is this substitution step? Assume करो कि input is 93. So we will simply check 9th row and third column. Whatever is the intersection, that is my new value after substitution. Getting it?
Yes, sir.
Yes. Okay. Similarly, अभी जो हमने एक एग्जांपल लिया था CB, so CB के केस में यहाँ पे C है और यहाँ पे कहीं पे तो B होगा. Fine. So इनका जो intersection है, that is 1F if I'm not wrong. So 1F is the current value of CB. So same thing happens with B1, B2, B3 and B0, and we will get some answer. Okay. So for example, मुझे मिला DC 10 for example. या तो मिल सकता है AB or for example 15. So suppose I got this value after this substitution step. ठीक है. चारों का एक साथ substitution करने के बाद suppose मुझे ये आंसर मिला. Now what happens is that entire value goes through XOR. If you see this, that entire value goes through XOR operation with this term, that is RCJ000. So in simple words, I can say that RCJ is nothing but a round constant. RCJ is nothing but a round constant, which varies for each round. It is a constant, but for that round only. So for example, now I am in the round number 1, so my RCJ is 01. Similarly for round 2, it is 02. Similarly for round 8, it is 80. Fine. So what happens over here is now we have, for example, we have this plain text with us after the substitution step. Okay. So DC 10 AB and 15 is my plain text after the substitution step. So what now happens is this DC, only this DC part, jitna DC ka part dikh raha hai, only this DC will be XORed with 0 1. That is, this DC will be XORed with the round key, that is 0 1 in this case, and rest all the values will be XORed with 0. Is it making sense? Kindly have a look. Because what happens is this round constant, if you see, it is nothing but 1 byte in length. So what happens is only the first byte will be XORed with the round key and the remaining bytes will be XORed with 0. So in short, for example, round 1 की अगर मैं बात करूं, so it is something like this. Let me write this one for you. And rest all zeros. So यहाँ पे 24 zeros आएंगे and this is nothing but your RCJ. Is it making sense? So the first byte B1 dash will be XORed with this value. So I'm writing it over here. B1 dash will be XORed with this value. Sorry, XORed with this value. ऐसा आएगा उसका direction, and we will get some output. Is it making sense? Can you let me know?
Yes, sir.
So B1 dash. Okay, thanks a lot. B1 dash is nothing but XORed with RCJ and we will get some output. Similarly, B2 dash will be XORed with all zeros, B3 dash with zeros and B0 dash with 0. Okay, chalo, thank you. So whatever be the output, that now becomes my W4 as per the diagram. So this process keeps on going on. So again, let me explain. W4 मिल गया अभी. Sorry, W4 नहीं. G का output मिला. G का जो output है, that is XORed with W0 and we will get W4. That W4 is XORed with W1 and you will get W5 and so on. जैसे ही W7 मिलेगा, that W7 again undergoes the same process जो भी G function था, same process वापस apply होगा, but this time the round value will be 02 instead of 01. And the entire process continues till we reach the 10th round, and at the end we will get some value called W40, 41, 42 and 43. Clear? तो इससे क्या होगा, हर एक राउंड के लिए मुझे 4 वर्ड्स के कीज ऑटोमेटिकली मिलते रहेंगे. Now is it clear? समझा ये पूरा प्रोसेस? Yeah, thanks a lot. So this is how we get the keys for each round, जो अभी हमने यहाँ पे डायग्राम देखा था.